Okay, hey, welcome back. In the last one, we wrote some pseudocode that will help our robot navigate this little maze that was down here. And so we ended up with move forward, right 90, move forward, right 90, move forward, left 90, move forward, left 90 again, move forward to the last part, and then we ended our program, and that will help us solve this maze here. And you can see all of those cards down there kind of walked us through it. Okay, so I'm going to get rid of those little cards, and now we're going to throw the robot down there and see if we can get this robot to drive the way we want it. But first of all, we've got to get a few things cleaned up from our old code. So you need to load your code from last time. We saved it right here, and we had tuned this, and yours might be different than mine. Mine seemed to work good at 81-degree turns. That would actually, even though we tell it to stop at 81, which would be bigger than 81, so 82, we found that it drifts a little bit. It goes about an extra 8 degrees, so that will get us right to 90, and that should be what we need to get through our maze today. First of all, let's get rid of this. Do you see this part? Keep the part that tells what a right and a left turn, the define parts. We're going to get rid of this part where we run it with the left button pressed, delete it. Get rid of this part, and we're going to keep the program setup, which has motor C and D, 40% speed, and 17.5% centimeters move. That's really important that you have that set up just like that. We'll never really mess with this part right here too much. We have a left turn set up and a right 90 set up, and we've tuned those. We have our pseudocode ready to go. All right, first thing we need to do is we need to find and make a block for move forward. So something that's going to move forward exactly one length in the PVC maze, just one. So let's go down here and let's make a block. And we're going to have this one move forward. I'm just going to call it move forward. Okay? That should work, and we're going to save that one. And so now we have another option. We have left, move forward, and right. Okay, cool. And that puts up this piece right here, which is move forward. So we have to tell it, when I say to move forward, what do we do? Tell the robot what to do. Okay, well, for this part, we need to take some measurements of our maze. So I'm going to go down here real quick, and we'll measure this, because what we need to know is, okay, fine. If we put our robot right in the middle right here, and we'll start at the same place every time, how much do we have to make it go to end up right in the middle here? How far is our move forward going to be? Get these out of the way. And we'll take, all we're going to do is we're going to take a measurement with our ruler. And we're going to find out how many millimeters that would be. Okay, so how far is it from middle to middle? Well, that would be the same. Middle to middle would be the same as corresponding pieces here. So I'm going to go ahead and measure this. To go from middle to middle, or to corresponding piece to corresponding piece, looks like our number is going to be right at 426 millimeters. Let me double check that. Yep, 426 millimeters. So for today's assignment, we're going to use the number 426 millimeters, and that should make our robot go forward exactly middle to middle. We don't want it to go all the way to the edge. We want it to stay in the middle. So it gives us a lot of room to mess up. And so this should be 426. Since the pipes are the same, these should be about 426. All of our forward spaces today should be about 426 millimeters. So let's go ahead and code that on the screen. Okay? So where it says move forward, we're going to define what does it mean to move forward in our code. You know what? I'm going to just stash this one right down here. And to move forward, we're going to start by putting a wait, 1 second. And that might be a little bit long. You know what? I'm going to change these wait times to 0.5 for all of my code right now. I think that would help. It's just going to speed things up. That way it's only waiting half a second for one thing to end and half another second for one thing to begin. So that'll just make it so that we have 1 second of wait because each time one thing ends, it'll wait half a second, and then the next thing before it begins, it'll wait half a second. So that'll be fine. Okay, I'm going to duplicate that and save that one right here for later. And I'm going to go up to the top, and I'm going to go here to movement, and I'm right in between those two, I'm going to set this. So what does move forward mean? It means wait a half a second, move forward, and we're going to change this to centimeters. Now listen, I've measured 426 millimeters. That's going to be 42.6 centimeters because it's 1/10, right? So we move the decimal place over one. So we're going to have that. Okay, great. That's awesome. We've got our move forward defined. Okay. So now what we're going to do is we're going to check out and see how that worked for our first part of our code. All right, and then we'll get to the pseudocode. And once we have this done, and we have our pseudocode set up and ready to go, this should be very, very simple. Just tell it what you need to do and put out the blocks that correspond to it. Let's check our move forward first. So we have to start our program, and I'm going to start my program by pressing the right button. So I'm going to bring this out, and when the right button is pressed, and I'm going to go down here, and we're going to start just grabbing our blocks that we made. Here's a move forward. So when the right button's pressed, we're going to move forward by waiting half a second, moving forward 426 millimeters, which is 42.6 centimeters. And then we're going to move, and we're going to wait half a second and go to the next part. Okay, so let me go ahead and program the robot. All right, so we've programmed our robot to move forward. If we did this right, put this down right in the middle. And if I did this right, when I press the right button, it should move forward about that far. Does that look like it's right in the middle? Yeah. Pretty good. Hey, that's good. That's a win for our first start. Now let's go back, and we need to make it go, we need to add a right turn like our pseudocode tells us. So now I'm just going to go through, and this is what's awesome, is that we've made the building blocks for everything. Now we just need to run our pseudocode, run through our pseudocode. Okay, if we look over here, let me kind of move this right over here so we can see all the pseudocode. So here we go. We have move forward right here. Okay, good. We're done with that. We need to write 90. Cool. Done with that. We have a move forward again. Move forward. And then it says we need another write 90. Cool. Now I don't want to go too crazy here because something could go wrong. Let's just test this and see if that works, what we have right now. So I'm going to get my robot, plug it into the USB, download the program, and put it back out there. Let's see what happens. Okay, so there we go. We've got our code running. I've got my code downloaded to the robot. Let's see how that thing works. Again, we're going to start by lining up our robot perfectly straight with the middles of the wheels right in the middle here. And let's run our code. So forward, half a second, turn, forward, wait half a second, turn. And there you go. Hey, that's pretty good start. Looks like our robot did what it's supposed to do. Okay, let's go back to our pseudocode and let's see if we can get this thing all finished up. Okay, so the next one is we need, on our pseudocode, it says we need to move forward. Since everything's going good, I'm just going to finish this up. We need a left 90. We need another move forward and left 90. I'm just going to duplicate. You see that trick I just used to skip through that a little faster. We need another move forward at the end. And then we need something that will stop the program. If you go back up here, control, oh, where'd it go? Here we go, stop and exit the program. All right, cool. So let's go ahead and grab our robot, and I'll put that code on here for the robot to run. Okay guys, have a great day. All right, so here's the moment of truth. Does our robot conquer the maze? See, we're going forward, we're turning right, we're going forward, turning right, forward. Now we should be turning left, forward, turn left, and we're good to go. You can see by the end we had a little bit of errors in our turns, and we didn't end up right in the middle. So, you know, hey, that's why we had to kind of tune it. Can you imagine if it would have been even worse than that? We wouldn't have even made it there. So that's why we tuned it. Even with tuning, it's easy to get this thing off by just a little bit. Okay, hey, thanks for watching, everybody. That'll show you how to do the first one. When you're done with that, show me that your robot is programmed. The next one, I'm going to be giving you a different maze that you have to write pseudocode for that you solve on your own. Thanks.